Look up the next time there's a full moon on the horizon. It will stop you mid-step. Huge, orange, close enough to touch. You will swear it is the biggest moon you have ever seen. And you will be wrong. The moon has not changed size. It never does. What you are looking at is one of the oldest, best documented illusions in the history of human perception. And after more than 2,000 years of study, scientists still cannot agree on exactly why it happens. Here is how to prove it to yourself. Next time you see a giant horizon moon, hold your thumb up at arm's length. It will cover the moon completely. Wait a few hours until that same moon is high overhead and do it again. Same thumb, same result. The moon subtends about half a degree of sky, roughly the width of your thumb at arm's length, and that number never changes, whether the moon is on the horizon or directly above you. Photographs confirm it too. A camera with a fixed zoom captures the exact same moon diameter at moonrise and at midnight. So the giant horizon moon is not really there. It is a trick your brain is playing on you. What makes this strange is how old the trick is. Ptolemy described it. Alhazen analyzed it in the 11th century. The philosopher Immanuel Kant wrote about it in 1781, noting that even an astronomer who knows the moon hasn't grown still can't help but see it that way. Knowing it's an illusion doesn't switch it off. Your reasoning brain and your seeing brain disagree, and your seeing brain wins. So, what's actually going on? The most widely cited answer starts with something called the Ponzo illusion, named after the Italian psychologist who described it in 1911. Picture two railroad tracks converging toward the horizon, with two identical bars laid across them, one near you, one far away. The bar closer to the vanishing point looks bigger because your brain reads the converging lines as depth and compensates for it. Apply that same logic to the sky. The horizon moon sits against a landscape full of depth cues, trees, buildings, distant hills, all pointing toward a vanishing point. The zenith moon floats in empty sky with nothing to compare it to. Kaufman and Rock tested this directly in 1962. Strip away the foreground depth cues, and the illusion shrinks. Add fake depth cues to the zenith moon, and it grows. It's a tidy explanation. It also has a hole in it. If your brain is inflating the horizon moon because it thinks it's farther away, people should report that the horizon moon looks farther away. They report the opposite. Ask people directly, and roughly 9 in 10 will tell you the horizon moon looks closer, not farther. Bigger and closer at once, like something magnified rather than something distant. Some researchers argue that's a reporting glitch. People know, logically, that the moon can't actually be closer, so their answer overrides what their eyes are telling them. Maybe. But needing that explanation, decades into the research, is itself a sign of how shaky the theory really is.
There's a second candidate, the relative size hypothesis. This one says an object's perceived size depends on what surrounds it. The same reason a circle looks bigger when it's ringed by smaller circles, an effect called the Ebbinghaus illusion. The horizon moon sits among small, familiar objects, trees, rooftops, hills, so it looks larger by comparison. The zenith moon is swallowed by open sky, so it looks smaller. Clean logic. Except astronauts on the International Space Station report seeing the same moon illusion. And up there is no foreground at all. No trees, no rooftops, just space. The theory can't explain that. Then there's the flattened sky model, the idea that we don't perceive the sky as a dome, but as a flattened surface, closer overhead and farther away at the horizon.
A moon of constant angular size would look bigger wherever that imagined surface seems farther. It's an old idea, and a 2023 study tested it directly. Researchers had 30 people point at where they believed specific landmarks would meet the sky, at distances from 3 meters to over 12 kilometers away. The results didn't match a flattened dome at all. What they found instead was a roughly 20-degree band right above the horizon where people's sense of sky distance turns genuinely unstable. And that band lines up almost exactly with where the moon illusion is strongest. The newest theory, from 2013, looks at binocular vision instead. The idea is that your brain treats the sky as one continuous surface, and the moon, by breaking that surface, creates a conflict between what each eye reports. To resolve it, the brain distorts the moon's projected size, and the effect is strongest near the horizon, where the perceived distance to the sky is shortest. It's an elegant model on paper, but other researchers have since pointed out a problem. People report the illusion even with one eye closed, and even in total darkness, where there's no binocular comparison to conflict with in the first place. So this one may not be the whole story either. 4 theories. None of them close the case. The Ponzo model explains the role of depth cues, but can't explain why people say the moon looks closer. Relative size makes intuitive sense, but can't survive the astronauts. The flattened dome has direct evidence against it. Binocular disparity runs into trouble the moment you take an eye out of the equation. A landmark 2002 review by Ross and Plug looked at decades of this research and concluded, simply, that no single theory has won. A 2013 book on the subject collected 19 chapters from different researchers, and they didn't agree with each other either. That's not scientists being cautious. That's an open question in perceptual science, sitting in plain sight, above your head, most nights of the month. And here's the part that makes it more than a curiosity. None of that uncertainty makes the illusion any weaker. It worked on Ptolemy 2,000 years ago. It worked on Kant, who described watching himself fall for it in real time. It works on astronauts orbiting 400 kilometers up with no horizon at all. And it will work on you the next time a full moon rises. Even now, even having heard every theory in this video. So go ahead and hold up your thumb next time. Prove it to yourself. Then let the moon fool you anyway, because some mysteries are better left a little unsolved. This is Reasonable Wonder. Big questions, clear science.